Usually when we look at like a legacy software system, there's always that one piece of code, right?
Oh, yeah. The spaghetti code.
Exactly. That ancient, tangled architecture that nobody wants to touch. It's bloated, it's inefficient, but it somehow keeps the whole operation running.
Right. So everyone just tiptoes around it.
Yeah.
You just pray it doesn't crash during a critical deployment.
Yeah. And the danger of that, if it isn't broken, don't fix it mentality, is that it actively creates systemic bottlenecks.
Totally. You patch it, you add shiny new UI widgets to the front end,
Mm-hmm.
but you never actually rewrite the foundational logic.
You just build layers of complexity over a flawed core. I mean, eventually you have to step back and realize that the hardware has evolved, the network has evolved, and your legacy code is just dragging everything down.
It is. It's dragging the whole system down.
And we are looking at an operational landscape that is, well, honestly, it's stuck in the past. And when we apply that metaphor to how we train human beings, how we actually impart knowledge, whether in a classroom or a boardroom, the realization is quite jarring.
It's the absolute definition of a systemic bottleneck.
Huh.
I mean, for decades, we've been running the most sophisticated hardware on the planet.
The human brain.
Right, the human brain. We've been running it on an operating system that was essentially cobbled together through guesswork and tradition.
So to you, the listener, whether you're an MBA student trying to structure a massive corporate training pipeline or, a junior software engineer designing intuitive user experiences.
Experiences that people actually need to learn how to use without throwing their laptops out the window.
Exactly. Understanding how the human brain acquires, processes, and retains information is the ultimate growth hack. It is the core operating system of human progress.
And today, we are skipping the basic definitions. We assume you know what a syllabus or a KPI is.
We are diving straight into the cognitive mechanics. Our mission today is to decode this operating system of human learning.
We're taking our source material, the book Creative Teaching, an evidence-based approach by Dennis Sale.
And we're using it to move teaching and training away from a legacy system based on fads and into an optimized, evidence-based science. And to tackle this dense material efficiently, this deep dive will operate under a strict, systemized protocol requested by you, the listener.
Right, we're breaking down all 6 chapters. For each one, I'll output a scannable framework, the big idea, an advanced deep dive, the connective tissue, a practical recap, and a critical thinking challenge.
And I'll prompt the system. When we finish a section, I'll literally say next to trigger the following chapter. So initiating protocol. Let's start with chapter 1.
Okay, chapter 1. The big idea here is that teaching is finally exiting what the author calls educational Jurassic Park.
Educational Jurassic Park. I love that.
It's great, right? It's exiting an era dominated by unverified fads and entering a scientific era governed by verifiable, high-impact heuristics.
So for the advanced deep dive, let's look at this legacy code of education, because the author critiques teaching as a creature of fashion, right?
Yeah, historically, teaching relied on shifting paradigms like moving from behaviorism to constructivism rather than actual empirical data.
He compares it to 1960s miniskirts, just whatever is trending.
Exactly. Or, archaic medicine. Imagine going to a modern hospital with a severe infection and the doctor pulls out a rusty saw and some leeches.
Because it's the current paradigm of the hospital wing. You'd run out of the building.
You'd be terrified. But education and corporate training have relied on that same kind of trial and error for decades.
And the author illustrates this with a wild anecdotal stat. He calculates he spent roughly 15,000 hours in the formal school system.
15,000. It's a massive investment of time.
And what did he retain? He specifically remembers learning about spirogyra.
Which is, for those who aren't botanists, a type of hermaphroditic pondweed.
Right, a completely isolated piece of trivia. And he grew up in the rough East End of London in the 50s and 60s. Why was pondweed a survival priority?
It wasn't. It had zero context, zero intrinsic motivation. His brain just rejected it.
But where did he learn actual life skills?
Boxing and football.
Yes, he learned boxing so he wouldn't get bullied. The formal curriculum gave him pondweed. The informal curriculum gave him survival, resilience, teamwork.
Which brings us to Martin's knowledge funnel. This is a core framework.
Okay, let's unpack the funnel.
So, human understanding moves from mystery-like, we have no idea how it works, think of early humans looking at an eclipse.
Right, pure mystery.
To a heuristic, which is a rule of thumb that guides exploration. And finally, it becomes an algorithm. a fully predictable formula.
So teaching used to be a mystery. We just threw information at people and hoped the trainer was a natural.
Exactly. But Sale argues teaching has moved into a heuristic. We have actual data-backed rules of thumb now.
And this data comes from John Hattie's meta-analysis, right? The Russian doll concept.
Yes. Hattie measured what works best using effect sizes. He found an effect size of 0.4. 0 is the hinge point for a year's worth of growth.
Wait, let me make sure I'm getting this. So anything above 0.40 is accelerating learning beyond the baseline.
Exactly. So take advanced organizers, giving students a visual map before teaching. It has an effect size of 0.37.
Which is just below the hinge, so maybe not a silver bullet.
But the ROI is massive. It takes 2 minutes to show a slide. The time cost is 0, but the cognitive return is huge. And when you combine these high-yield methods, you get the Russian doll effect.
Yeah, a nested, synergistic instructional strategy.
Right.
But I got to push back on this Russian doll idea. If I just stack high-effect methods like software patches, an advanced organizer here, a feedback loop there, doesn't it become bloated?
That's a very real risk.
Because the author specifically warns that too much of a good thing leads to habituation. How do we balance stacking with cognitive overload?
Well, stacking without strategy is absolutely cognitive bloatware. The Russian doll metaphor implies nesting, meaning the tools must fit perfectly within one another in a logical sequence.
So it's about architecture, not just throwing features at the user.
Precisely. You use the advanced organizer to set the stage, which reduces cognitive load. You use feedback at specific friction points, not constantly.
Okay, so what's the connective tissue here?
Chapter 1 proves that teaching can be quantified. Chapter 2 will define the specific code, the exact heuristics that make up this new pedagogical operating system.
Got it. Let's do the practical recap for Chapter 1. Point 1. Abandon folk psychology like learning styles. Rely on empirical effect sizes.
Point 2. Map your training methods on Martin's knowledge funnel to see where your processes are stuck in mystery.
And point 3. Use the Russian doll strategy to nest high-impact interventions, but monitor for habituation. So here's your critical thinking challenge. In your current organization, what training practices are creatures of fashion rather than evidence-based?
And secondly, if you were to audit your team's onboarding process, how would you measure its effect size using Hattie's comparative logic?
Love that. Next, moving to Chapter 2.
All right, Chapter 2. The big idea. Effective learning is governed by 10 interdependent core principles of learning that function synergistically to optimize the brain's acquisition, processing, and retention of information.
Let's get into the advanced deep dive, the cognitive architecture. The author starts with motivation, right?
Yeah, and he goes straight back to Jeremy Bentham. Motivation is driven by the pursuit of pleasure, the avoidance of pain, and the desire for novelty.
And the chili crab analogy. I love this.
It's so relatable. He moves to Singapore, tries chili crab, and the pleasure and novelty are off the charts.
So he eats it every night for 2 weeks, but then the appeal is just gone.
Right. The novelty wore off. It became habituation.
Which segues into memory systems, because habituation is a memory function.
Exactly. We have to look at the severe bottleneck of working memory versus long-term memory.
Working memory being where your active consciousness lives right now.
Yes, and George Miller's research shows working memory can only hold about 5 to 9 bits of information, and only for about 15 to 30 seconds.
That is a tiny workspace. If you're designing a UI or an onboarding flow, getting data through that 5 to 9 bit bottleneck into the infinite hard drive of long-term memory is the whole ball game.
It really is. And to do that, you have to understand Murdoch's serial position curve.
The primacy and recency effects, right? You remember the first few items on a list and the last few?
But the middle is a dead zone. Unless, and this is key, use the von Riestorff effect.
Yes. The glowing red text in the middle of a boring black and white slide.
Exactly. Novel outliers stick in the brain regardless of position. It bypasses the System 1 filtering.
Speaking of System 1, let's talk about good thinking. The author uses Kahneman's model. System 1 is fast and reflexive. System 2 is analytic but lazy.
Very lazy. Learning requires System 2, which causes ego depletion. It drains your cognitive stamina.
So Sale's model is about generating possibilities, analyzing, inferring, but doing it carefully to avoid too much ego depletion.
Right. And knowing these principles is pedagogic literacy. But applying them requires deliberate practice, building mental models to move from novice to expert.
Okay, here's where it gets really interesting for me. The author uses a fly fishing analogy. You can't just apply an algorithm to catch a fish. You have to read the water, the weather, the bugs.
It's a dynamic environment.
In management terms, this is agile methodology. You have a framework, but you must iterate based on real-time feedback. But how does a novice teacher or manager read the room when their working memory is already maxed out just trying to deliver the content?
The painful truth is they can't. A novice's working memory is entirely consumed by the intrinsic cognitive load of the task.
So they're just surviving up there.
Exactly. This is why deliberate practice is required before the performance. You have to proceduralize the content, move it to System 1, so your working memory is freed up to actually read the room and be agile.
Automate the baseline to unlock agility. That is huge. So connective tissue.
Chapter 2 gives us the underlying cognitive heuristics, but applying them in unpredictable environments requires something more agile. That brings us to Chapter 3, creativity.
Awesome. Practical recap for Chapter 2. 1. Design presentations leveraging the von Riesterf effect. Place critical data points in novel formats to bypass System 1.
2. Segment complex information to prevent working memory overflow. Extrinsic cognitive load is your enemy.
And 3. Implement 1-minute papers or quick check-ins to gather immediate formative feedback.
So your critical thinking challenge, how can you redesign a boring weekly update meeting to leverage the primacy and recency effects?
And secondly, where in your workflow are you expecting System 2 analytical thinking from your team, but inadvertently providing an environment that triggers System 1 reflexive thinking? Okay, next, let's hit Chapter 3.
Chapter 3, the big idea. Creativity in teaching is not an innate mystical talent. It is the systematic, deliberate combination of existing knowledge into novel, useful forms to solve specific learning bottlenecks.
Advanced deep dive. Let's define creativity, because it's not just being weird, right?
No, Amabill's definition is strict. A product must be both novel and useful or appropriate to the context.
And we're not talking about big C creativity here, like winning a Nobel Prize.
Right, Fasco's continuum. We're talking about little c creativity, everyday problem solving, like adding butter to your coffee for sustained energy.
Novel and useful. I like it. So what are the neurological mechanics of that aha moment?
Well, De Bono theorizes the brain is a pattern-making system. It wants to be efficient. So creativity requires chance provocation to break existing neural pathways.
Which brings us to Percy Shaw. I love this story.
It's the perfect example. He's driving on a foggy, dangerous road in the 1930s. He's stuck in his mental pattern of needing brighter headlights.
And then his headlights catch a cat's eyes on a fence.
That random chance provocation forced a lateral connection. He combined the cat's reflective eyes with road safety and invented the reflective road stud.
Little c creativity scaling into massive global impact, but we can't wait around for random cats in the fog.
No, we have to engineer those provocations, but it takes time, which brings in Claxton's concept of the undermined.
The intelligent unconscious.
Yes. Creative solutions are slowly brewed in the neural reconfigurations of long-term memory before flashing into conscious thought. Stepping away from a problem is a valid neurocognitive strategy.
Okay, my pushback here. If the brain is a pattern-matching machine designed to be efficient, meaning lazy, then creativity is technically an active neurological rebellion.
It is, yeah.
If I'm leading a team, how do I force chance provocations without derailing our quarterly KPIs? We can't just all go take walks and host the undermine solves the sprint bottleneck.
You have to constrain the provocation. You don't blow up the KPI. You introduce a random engineered constraint. Like asking your devs, how would we build this if we had 1/10 the server space?
So you schedule the provocation, you put a time box around it.
Exactly. It severs the existing comfortable neural pathway and forces a lateral connection without derailing the project.
That's incredibly practical. Connective tissue.
We understand the syntax and neurological necessity of creativity. Chapter 4 provides this specific behavioral framework to actually deploy this little C creativity in front of an audience.
Practical recap. 1. Stop waiting for big C inspiration. Engineer little c creativity by combining 2 existing, unrelated concepts in your field.
2. Intentionally introduce chance provocations, like random constraints, into brainstorming sessions to disrupt established neural patterns.
And 3. Allow time for the undermine to process. Stepping away is not procrastination.
Your critical thinking challenge. Think of a persistent communication bottleneck in your team. What is a little c creative intervention you could deploy tomorrow?
And how can you structure your project sprints to allow for Claxton's undermine brewing time? Love it. Next, moving to Chapter 4.
Chapter 4, the big idea. Educators and leaders can systematically operationalize creative teaching competence using the SHAPE framework.
SHAPE. Stories, humor, activities, presentation style, and examples.
Right. But first, the advanced deep dive starts with the illusion of magic. The author uses David Blaine as an analogy.
Right, because when Blaine bites a coin in half, a novice thinks it's magic. But it's actually meticulously rehearsed expertise.
Exactly. And a great presentation is the same. It looks like natural magic, but it's just the deployment of Shapey.
Let's unpack the acronym. S is for stories.
Because stories contextualize data. They bypass System 2 filters and speak to deeper schemas.
Pace is humor. Not being a stand-up comic, but using it as a cognitive reset. Right.
Yes, it reduces stress and introduces novelty, satisfying Bentham's motivation criteria.
A is activities, moving learners from passive reception to active processing.
Using essential questions, how and why to force System 2 thinking.
P is presentation style, the pedagogic glue, posture, voice calibration, and the text mentions Wadd's research here.
Wadd's research on first encounters is critical. Initial interactions permanently lock in perceptions of the psychological climate.
It's terrifying. And finally, E is for examples. Analogies acting as bridges between existing mental schemas and new concepts.
Without examples, abstract concepts just float away.
So if we connect this to the bigger picture, I think of SHAPE like a UI/UX toolkit for human attention. But the author says, the meaning of your communication is the response you get. What happens when the UI fails?
Like the Geraldine story.
Yes. The author's disastrous first date, he lacked the prior knowledge to converse with her, so he just talked about boxing. If our shape is wrong for the audience, how quickly can we pivot?
Your pivot depends entirely on your metacognition thinking about your own thinking. If the UI fails, you have to immediately drop an activity.
You throw a question back at the audience.
Exactly. You ask them how they would solve the problem. It re-engages them, and more importantly, it buys your own working memory time to formulate a new strategy and find a better example or story.
You switch from broadcast to listening mode to rebuild your shape on the fly. Brilliant. Connective tissue?
Shape works beautifully in a localized face-to-face environment. But how do these organic touchpoints scale in distributed or digital systems? That leads us to Chapter 5.
Practical recap. 1. Audit your next presentation. Does it have a clear shape, or is it just a data dump?
2. Use essential questions to force System 2 thinking rather than closed memory questions.
3. Treat your presentation style as pedagogic glue. Modulate your voice and pacing.
Critical thinking challenge. Recall a recent presentation that failed to engage the room. Which element of shape was missing?
And how can you use humor not just for entertainment, but as a deliberate cognitive reset for an exhausted team? Awesome. Next, Chapter 5.
Chapter 5. The big idea. Blended learning is only effective when information communication technologies, ICTs, are deployed to serve evidence-based pedagogy, rather than letting the technology dictate the learning design.
Advanced deep dive. We got to talk about the brain versus the computer. So Wester's research.
Right. Computers are excellent at processing complex, clearly defined facts rapidly.
Like sorting a massive database.
Exactly. The human brain is actually terrible at that. But the brain is superior at conceptualizing ambiguous problems and formulating ideas. Blended learning must assign tasks accordingly.
But when we ignore that, we get what the author calls digital dumps.
The absolute worst. Uploading massive text files and ignoring the limitations of working memory.
Just because the cloud has infinite storage doesn't mean the human brain has infinite bandwidth.
Exactly. So to fix this, the author outlines mapping online learning, like high-end hotel customer service.
Mapping the touch points.
Yes. Identifying critical touch points like points of confusion and programming delighters. Unexpected positive interactions that maintain the psychological climate digitally.
Okay, let's unpack this with a pushback. The author mentions an email internet training course he took that left him completely confused. He couldn't even open Netscape.
A total failure of pedagogy.
Right, it proves technology without pedagogy is useless. But in the tech world today, we are obsessed with tools. Slack, Asana, Notion, Figma. Are we mistaking moving information around for actual collaboration and learning?
We absolutely are. We bend our workflows to fit the software, rather than making the software serve our cognitive needs. You should only deploy a tool if it specifically enhances a core principle of learning.
Form follows function. The software must serve the brain, connective tissue.
We have the heuristics, the creative syntax, the behavioral framework, and the digital strategy. The final missing piece is system-wide implementation. How do we train the trainers? Chapter 6.
Practical recap for Chapter 5. 1. Never digitize a bad analog process. Applying technology to poor pedagogy just scales the failure.
2. Offload rote data processing to software, reserving human interaction for ambiguous problem solving.
3. Map out the digital touch points of your remote team's workflow and insert intentional delighters to boost morale.
Critical thinking challenge. Look at your organization's tech stack. Which tools are actually facilitating deep understanding and which are just causing cognitive overload?
And if you were to design a hybrid onboarding program, how would you divide the tasks between asynchronous digital modules and synchronous human mentorship? All right, next. Final stage, Chapter 6.
Chapter 6. The big idea. To cultivate adaptive, creative experts, institutions must abandon piecemeal motivational seminars in favor of structured, deliberate practice embedded within the actual work environment.
Advanced deep dive, the complete failure of standard professional development.
It fails because it ignores the core principles of learning. It lacks deliberate practice, chunking, and follow-up.
It's just a digital dump in a conference room.
Exactly. So Jeff Petty suggests supported experiments and active schemes of work.
Let's define those.
A supported experiment is a trial of a new evidence-based strategy supported by peer review, just one heuristic at a time.
Like a localized beta test.
Right. And active schemes of work act as living, collaborative blueprints where those best practices are documented, preventing institutional knowledge from walking out the door.
And the text makes a big distinction between novice and expert reflection here.
Yes. Novices view situations as discrete elements and rely on strict rules. Experts perceive integrated patterns and can fluidly adapt. That's the essence of creative teaching competence.
This raises an important question, though. The author points out that telling a teacher to be interesting is as useless as telling a teenager to be interesting on a first date.
Intent does not equal competence.
Exactly. If an organization wants an agile workforce, shouldn't they be funding these supported experiments with a recognized margin of error, rather than just demanding innovation and punishing failure?
They absolutely must. You can't demand adaptive expertise while enforcing rigid compliance. A supported experiment requires psychological safety. The learning extracted from a localized failure is the long-term ROI.
If you punish the failure, you lock them in System 1 panic and kill the undermine.
Exactly. You kill the creativity.
Okay, practical recap. 1. Replace passive training seminars with supported experiments where team members test a specific heuristic in the field.
2. Create an active scheme of work, like an internal wiki to capture the localized expertise of your top performers.
3. Shift performance reviews from rule compliance to adaptive problem solving.
Critical thinking challenge. What is one supported experiment you can run with your team this quarter?
And how does your organization currently capture the illusions of magic performed by your top talent so that others can replicate them?
That's the whole system right there.
It's an incredible blueprint. So let's hit the outro. Give us that final provocative thought.
All right, so Martin's knowledge funnel dictates that we move from mystery to heuristic to algorithm. Sales book successfully pulls teaching firmly into the realm of heuristics. But here is the provocative thought. With the rapid acceleration of AI and machine learning, are we approaching an era where the heuristics of human learning are fully transformed into an algorithm? Think about it. If an AI can perfectly monitor pupil dilation to calibrate cognitive load, if it can implement the von Riestorff effect at the exact millisecond attention wanders, if it dynamically adjusts to your 5 to 9-bit working memory limit, what happens to the art of human teaching?
Does the human element become obsolete?
Or does the pedagogic glue of human connection, the empathy, the shared psychological climate, become the only premium value left?
Wait, really? If the algorithm is flawless, the only thing it can't replicate is the actual human messy context. That is a wild thought to leave on.
It changes how we view our entire role as leaders.
It really does. Well, you asked us to decode the architecture of learning, and you just got the blueprint. Whether you're managing a code base or a boardroom, you now have the heuristics to hack human attention and memory. Take these principles, run your own supported experiments, and we'll catch you on the next deep dive.